Hello, and welcome to another Unity tutorial. In this video, we will learn how to make a first-person controller using Unity's new input system, covering horizontal movement, custom gravity, and jumping to a desired height. If this video helps you, remember to smash like and subscribe, and without further ado, let's get started. I have opened a blank 3D project and not done anything to it yet. The new input system is not included in projects by default, so to use it, we will have to go to the Package Manager from Window, Package Manager, give it a moment to load, and then search for Input. Select the input system, and then at the bottom select Install. If you have not downloaded this package before, the button will say Download instead. Once it finishes installing, we will be asked if we want to change the default input handling from using the old input system to the new input system. We do, so click Yes, and then wait for the editor to restart. Once the editor opens up, you may see this error here, telling us that the 32-bit version of Windows is not supported by the input system. I believe that it is safe to ignore it, as I have never had any problems doing so before, but if you want to make it go away, simply go to File, Build Settings, and set the architecture to 86_64, and that will solve the problem. Just to prove that it works without doing this, I will leave it as the default settings. Now in the hierarchy, I can right-click and create a new plane. I will call this ground, then set its scale on the X and Z both to 3. I'll also reset its transform position. Next, I'll click on the Layers drop-down and select Add Layer. In the next empty slot, I'll add a ground layer, and then go to our ground object and assign the layer. Next, we will be creating the player, but before we do so, I think it would be beneficial to talk about the different types of controllers you can make. There are two main ways to make a player controller in Unity: a physics-based approach using a rigid body, and a non-physics-based approach using a character controller. Each of them have their own advantages, some of which are on the screen now, and which one you choose ultimately depends on what type of game you are making. For example, if your game has lots of interactions with other physics objects, a rigid body would work well, but if you don't have many physics interactions and have lots of slopes and stairs, a character controller would probably suit your game better. With that in mind, we will use a character controller for this tutorial, as it is smooth, customizable, and a great all-round controller that works pretty much out of the box. With that in mind, I will create an empty object and call this player. I'll reset its transform, then add a component to it, which will be the character controller. If I now turn on the gizmos in the scene view, select our player, then hit F to focus on it, you'll see a green outline showing the boundaries of our player. I will set its height to 3, radius to 0.6, just to make it a little bit bigger, and then its center on the Y to 1.5 so that it stands on the ground. Now if I right click on the player, I can add a capsule component, which allows us to see it. We can remove the collider, since the character controller deals with all collisions, and set its scale to 1.2 on X and Z and 1.5 on the Y. I will also set its position on the Y-axis to 1.5 so that it stands on the ground. Finally, parent the main camera to the player by dragging and dropping it on, reset its transform, and then drag it up on the Y to approximately where the eyes of a player would be. With the game objects all in place, let's create a new folder. So right click in Assets, Create Folder, and I'll call this Player. Inside of this, I will create a new input actions, which we got from the input system package, and call this Player Controls. Make sure to check Generate C# class, and then click on Edit Asset. This window may look confusing at first, but it is really quite simple. On the far left, we have action maps. These are just large containers in which we can store actions. Actions are defined in the middle and are simply input from the player, such as holding down W or pressing space. On the right, you can see the properties of different actions, allowing us to customize them with dead zones, double taps, and other cool stuff. To see that in action, create a new action map and call it ground movement. Select the default action, and I'll hit F2 to rename it, and I'll call this horizontal movement. Then set its action type to pass through, meaning to continuously listen for input as opposed to a one-time press, and then its control type to a vector 2. Delete the default binding by clicking on the arrow to expand it, then right-click delete, and then I'll add a new 2D vector composite. I'll call this WASD. Now I can set the up to W, down to S, left to A, and right to D. All of that tells Unity continuously listen for any of the keys W, A, S, or D being pressed, and if they are, update the horizontal movement action. If W is pressed, we will have a vector 2 of 0 on the X and 1 on the Y. If A is pressed, we will have a vector 2 of negative 1 on the X and 0 on the Y, and so on. Now let's create another action, which I'll call jump. We'll set its binding to space, then save the asset and close it. You will see that it automatically generated a new C# class for us. Right-click in our player folder and create two new C# scripts. The first one will be movement, and the second one will be mouse look. These are the scripts that we will use to actually move the player and its components. We will also need one more script, so right-click and create C# script, and this will be the input manager. Now I can shift-click to select them all and open it up in Visual Studios. In the input manager, we will start off by setting up the basics of the new input system. We need a reference to the input controls that we just made, so create a new variable, which will be type of player controls, and I'll call this controls. Underneath that, create another variable, type of player controls dot ground movement actions, and I'll call this ground movement. This will just save us from typing player controls dot ground movement actions every time we want to access an action. Now in the awake function, we can set controls equal to new player controls and ground movement equal to controls dot ground movement. When using the new input system, we also have to remember to enable it or it won't work. So in on enable, we'll say controls dot enable, and then the same on disable. So on disable, controls dot disable. Great, everything is now set up for us to start using the new input system. To get input, we use the syntax ground movement dot action dot performed plus equals context and then an arrow, and then we say what we want it to do. Context is a variable which contains information about the press, and in the do something part, we can call a function or set a variable. To get input from our WASD keys, I will first create a new variable, which will be vector2 horizontal input. And then in the awake function, I can say ground movement dot horizontal movement dot performed plus equals ctx, short for context, and then I want to set horizontal input equal to context dot read value vector 2. This looks quite complicated, but you'll understand what it does quite soon. To move the player, we will use the movement script, so go into it and then create a new variable which will be vector2 horizontal input again. We will need a function to receive input, so this will be public void receive input. This will take input type of vector2, and I'll call this horizontal input with an underscore to differentiate it. Inside here, all we have to say is horizontal input is equal to the horizontal input. Now in the input manager, I can get a reference to our movement script using serialized field movement, and I'll call this movement with a lowercase m. Now in the update function, which is called every frame, I will say movement dot receive input, and I'll pass in the horizontal input. To make sure that it's working, I'll quickly go back into our movement script, and then underneath here I'll print horizontal input. Now let's return back to the editor. We can ignore these warnings for now, then select our player and drag on all of the scripts that we just made. Make sure to assign the movement script to the input manager, and then hit play. You'll see that nothing much is happening in the game view, but in the console you can see 00 being printed. If I hold down the W key, you can see that 01 is now being printed. If I hold down the A key, you can see that -1, 0 is being printed, and same for the S and D keys. Great. Now let's make the player actually move. Back in the movement script, we're going to create two new variables. These will be serialized field character controller, and I'll call this controller, as well as serialized field float speed, and by default I'll set that to 11. Now in the update function, we can say vector3 horizontal velocity is equal to transform dot right multiplied by horizontal input dot x plus transform dot forward multiplied by horizontal input dot y. We also want to multiply this whole thing by speed, so add parentheses around it and then multiply by speed. Then we can say controller dot move horizontal velocity multiplied by time dot delta time to give us constant movement speed regardless of the frame rate. We can now return back to the editor, then drag and drop our character controller into its slot. I'll zoom out in the scene view so you can see what's happening, then hit play. Great, the player seems to be able to move with 8D movement. However, if I drag the player into the air, you'll see that there is no physics acting upon it, so it just floats there, and we can actually move around in the air. To solve this, exit play mode, and let's return back to the script. I'll create a new variable, which will be serialized field float, and I'll call this gravity. And for now, I'll set this equal to -30. I know that it should usually be -9.81, but I've tested it out, and -30 has a much snappier feel to it. You can of course use any value that you want to. Under this, I'll say vector3 vertical velocity is equal to vector3 dot 0. Now in the update function at the bottom, I'll say vertical velocity dot y plus equals gravity times time dot delta time, and then I can say controller dot move vertical velocity multiplied by time dot delta time. You might be wondering why I multiplied by time dot delta time twice, but that's simply the physics equation of a free fall. Now if I return back to the editor and hit play, if I drag the player up, you'll see that it falls to the ground. However, if I keep dragging it up repeatedly, you'll see that it falls faster and faster until it eventually seems to almost teleport to the ground. This is because in our script, we keep on increasing our vertical velocity, but we never reset it when the player is on the ground. To do this, let's create a new variable. This will be serialized field layer mask, and I'll call this ground mask. We will also need one more variable, which will be bool is grounded. And now in the update function, we can set is grounded equal to physics dot check sphere. For the center will be our transform dot position. The radius will just be an arbitrary small number, so 0.1f, and the layer mask will be the ground mask. Physics.checkSphere casts an invisible sphere at the location of our player, with a radius of 0.1, returning true if it intersects an object with the ground layer, and false if it doesn't. Now I can say underneath here, if is grounded is true, then we want to set vertical velocity dot y equal to 0. Now I can return back to the editor, assign the ground mask the ground layer, and then try testing it out. If I drag the player up into the air, you will see that it falls down slowly, and there's no sign of it speeding up over time. Great, now let's add a jump to the player. To jump to a specific height, we can use the equation v is equal to the square root of -2 times the jump height times gravity. To implement this, I'll create a new variable. This will be serialized field float jump height, and I'll set that equal to 3.5 by default. I'll also create a new bool, which I'll call jump. Now we need to create a new function, so I'll do this at the bottom, and this will be public void on jump pressed. It won't take any input, and inside it, all we have to do is set jump equals true. Now in the update function, before we update our gravity, I can say if jump, if we are also grounded, then vertical velocity dot y is equal to mathf dot sqrt for square root -2 multiplied by our jump height multiplied by gravity, as per the physics equation. And after this, we have to remember to set jump equal to false. In the input manager, we have to include our jump, since we haven't done that yet. So underneath the horizontal movement, I'll add ground movement dot jump dot performed plus equals underscore. Since we don't need any of the context information, underscore is just a discard variable. And then we want to call movement dot on jump pressed. We can now return back to the editor, and this should be working. I'll hit play. We can move around, and if I hit space, we jump. Great. You can also see that gravity is a variable here, so I can set it to anything, such as -30, which I believe feels much snappier, or even go so far as to say -60, which is a bit too fast for me. You can set this to anything that you would like to. I'm going to leave it at -30 for now. Now let's use input from the mouse to look around. When we move the mouse on the x-axis, we want to rotate the player on the y-axis. Since that is what will make it rotate horizontally. When we move the mouse on the y-axis, we don't want to rotate the player, but instead only rotate the camera on the x-axis. To do this, let's go back into our player controls, edit the asset, and create a new action. I'll call this one mouse X. Set its action type to pass through, and control type to axis. I'll set its binding equal to delta X on the mouse. Delta just means how much has it moved. I'll right click and duplicate this action and rename this to mouse Y. and change its binding from delta x to delta y. Remember to save the asset and then close out. Now let's go into our mouse look script, and inside here we can create two variables. These will be serialized field float sensitivity x, and I'll set that equal to 8, and I'll create a new one, serialized field float sensitivity y is equal to 0.5f for now. I'll also create a new variable which will be float mouse x, and also another one for mouse y. Now we need to do the same thing as in the movement script. So public void receive input, and this will take in a vector2 for the mouse input. I'll set mouse x equal to mouse input dot x and mouse y equal to mouse input dot y. We'll also have to remember to multiply both of these by the corresponding sensitivity. Now above here, I'll create an update function, and I'll say transform dot rotate around vector3 dot up, which is the y-axis, and I want to rotate by mouse x multiplied by time dot delta time. Now in the input manager, I'll create a new variable for the script, serialized field mouse look, and I'll call this mouse look. I'll also create a new vector2, which will be mouse input. Now in the awake function, I can say ground movement dot mouse x dot performed plus equals ctx, and then I want to set mouse input dot x equal to the context reading the value of a float. I'll do the same for mouse y, just copying and pasting that line. And now in the update function, I will also say mouse look dot receive input, and I'll pass in the mouse input. Now we should be able to go back to the editor, and this will only work for the horizontal movement for now. Select our player, and make sure to assign the mouse look to its corresponding slot, then hit play. If I move my mouse around, you can see that we can look around on the x-axis, but moving my mouse up and down doesn't do anything. Of course, we can still jump and move around. Great, let's exit play mode and return back to our mouse look script. In here, I'll create a new variable, which will be serialized field. This will be transform, and it will be the player camera. I'll also create a new variable, which will be type of float, and this will be the X clamp. I'll set this equal to 85 by default. We use a clamp to ensure that the rotation never goes too high or too low, so that the player can look directly behind them, since that isn't how most FPS games work. I'll also create a float for the current X rotation, and set that equal to 0 by default. Now in the update function, at the bottom, I can say X rotation minus equals mouse Y. You might be wondering why we're using minus equals and not plus equals, but you can try them out, and you'll find that if you use plus equals, the controls are reversed as to what is normal. Next, I'll say X rotation is equal to mathf dot clamp. I'll clamp X rotation between negative X clamp and positive X clamp. Finally, I can say vector3 target rotation is equal to transform dot Euler angles to get the current rotation of the player, and then target rotation dot X can be set equal to X rotation. Now I can set the player camera dot Euler angles equal to the target rotation. Great, this script should now be done. Let's return back to the editor. Make sure to assign the player camera into the mouse look script and hit play. As you can see, I am now able to look around freely, move, and also jump. Just to quickly fix up some things in the script, I'll return back into the movement script and remove the print statement since we don't need that anymore. And at the top, I'll also include hashtag pragma warning, disable, and I'll say disable the 649 warning. What this means is that if we return back to the editor, these errors that tell us that a variable will never be assigned will go away. This is because when we use a serialized field, we are expected to assign the variable a value immediately, as Unity doesn't realize that we can assign the variable in the inspector. We will do the same thing with the mouse look script, and now if we return back to the editor, those warnings should be gone. You can see that we have two more, and these are from the input manager script, which I forgot to do. So now if we return back to the editor, everything should be fixed and all working. I'll clear the console, maximize the game view, and now we can play. Great. There's one more cool thing that you can do with the character controller, which is if you go into the inspector, you'll see all of these values that you can play with. For example, step offset defines how big a step the player can move up. So if you have stairs in your scene, the player should already be able to move up them without any further scripting. The slope limit is the same, but for slopes. Apart from that, just mess around with it, have some fun, and learn cool new things. That's it for this tutorial. Thanks for watching, and I'll see you next week.